We know that atmosphere is a blanket of gases around the planet. This blanket or the atmosphere is held close to Earth's surface by the gravitational force exerted by the planet. Today, we are going to look into the topic of structure of the atmosphere in some detail. As we already know, the Earth's atmosphere is composed of a mixture of gases like nitrogen, oxygen, carbon dioxide, argon, and other particles like water molecules and dust particles. For the first 90 km from the Earth's surface, the atmosphere's composition is somewhat uniform, and hence this part is known as the homosphere, that is, the part with uniform composition. But beyond 90 km, there is no uniformity in the gaseous composition, and this part is known as heterosphere. Also, in the heterosphere, the at different levels, the temperature changes. The temperature change shows different patterns, and based on these characteristics, the atmosphere can be divided into different layers. Each layer in the atmosphere has its own indigenous characteristics. The different layers of atmosphere are troposphere, stratosphere, mesosphere, and thermosphere. So, the different layers of the atmosphere are troposphere, stratosphere, mesosphere, and thermosphere. Let us look at each of these layers in some detail. The first layer is the troposphere. As we saw in the picture, this is the layer that is closest to the Earth's surface. This layer extends up to an average altitude of 13 km from the surface of the Earth. And as we already said, this layer lies closest to the Earth. Although we talked about an average altitude of 13 km, in the equatorial regions, the troposphere can gain a height of up to 18 kilometers. This is because of the strong convection here. That is, in the equatorial regions, the air experiences strong upward draft. This pushes the troposphere to a much higher level, that is, up to 18 kilometers. And the most important role or the phenomenon in the troposphere is the climatic phenomena such as the cloud formation, rain, snow, wind, thunder, and lightning. So we can say that almost all the weather and climatic phenomena such as cloud formation, rain, snow, wind, thunder, lightning, etc. take place in this layer. Troposphere also experiences or exhibits another characteristic, that is the normal lapse rate. It is that the temperature in this layer decreases at a uniform rate of 1 degree Celsius for every 165 meters of altitude. This is called normal lapse rate. This is why as we climb mountains, the temperature decreases and it gets colder. The zone of transition above the troposphere is called tropopause. In other words, tropopause is the boundary between troposphere and the next layer of the atmosphere called as stratosphere. Stratosphere is the second layer away from Earth's surface. It extends up to a height of about 50 km from the Earth and lies above the tropopause. In the lower part of the stratosphere, there is no change in temperature with altitude. That is, the temperature remains the same along the lower parts of the stratosphere. This zone is called the isothermal zone or the zone where the temperature is stagnant. Iso means same temperature. Beyond this, there is an increase in temperature with altitude. So in the stratosphere, in the lower parts, the temperature remains the same. And beyond the isothermal zone, the temperature increases with altitude. In the stratosphere, we saw that the temperature decreases with altitude. The ozone layer is found in the stratosphere, or we can say that the ozone layer forms a part of the stratosphere. The ozone layer, which forms part of this layer, absorbs the harmful ultraviolet rays from the sun and prevents them from reaching the earth. As it is a common knowledge, we all know that ozone uh, protects us from the harmful ultraviolet rays. We know that ultraviolet rays can cause serious diseases like skin cancer, and the stratosphere, with the help of ozone, plays a very important role in protecting us against these harmful rays. Also, stratosphere is free from all the weather and climatic phenomena. Hence, the atmospheric condition is almost clear. So, this allows the free movement of jet aircrafts through clear atmospheric conditions and absence of air gutters. The zone of transition above the stratosphere is called tropopause. So, stratopause forms the boundary between stratosphere and mesosphere. Mesosphere extends from 50 km to 80 km altitude from the Earth. Temperature decreases with the altitude, and the lowest temperature at the atmosphere is felt at the mesopause. So just like troposphere, the temperature in the mesosphere also decreases with the altitude. So if we are to like classify, in the troposphere, the temperature decreases with altitude. In the stratosphere, in the lower parts, the temperature remains same, and this zone is known as the isothermal zone. Beyond the zone, the temperature increases, whereas in mesosphere, temperature decreases with altitude. The meteors on reaching the mesosphere get burned out due to friction. We have often seen news about how meteors coming towards Earth, and this layer, that is the mesosphere, is the layer that is protecting us from such giant meteors. That is, if the meteors were to collide with the Earth, then it would be affecting the life on Earth in a negative way. Or in more serious terms, even life on Earth would not have been possible. So due to the friction in the mesosphere, these meteors get burned and does not fall on Earth. This makes life on Earth possible. The zone of transition above the mesosphere is the mesopause. The next layer of the atmosphere is the thermosphere. This layer extends from about 80 to 600 kilometer altitude. There is considerable increase in temperature with altitude. This is because as the altitude increases in this region, it gets closer to the sun. So there is direct influence of sun and solar flares. Because of this, in this layer the temperature increases with altitude. The lower part of the thermosphere is known as the ionosphere. That is, the region of the thermosphere from 80 to 400 km is known as the ionosphere. At this altitude in the atmosphere, the intense solar rays such as ultraviolet rays or the UV rays, X-rays, etc., react with the gaseous molecules to form ions. That is, when such rays are like come in contact with the gases like oxygen, carbon dioxide or nitrogen or and even hydrogen, these molecules will react with these rays and get ionized and form ions. This process is called ionization, and the part of the atmosphere is called the ionosphere. Ionosphere helps in the transmission of radio waves. This is because as the molecules get ionized, as the gas molecules get ionized, they are able to conduct electromagnetic waves. They can conduct electricity and electromagnetic waves, and radio waves are electromagnetic waves. So, the ionosphere is helping in the transmission of radio waves, which are important for sending signals and transmissions. So, today we looked at the topic structure of the atmosphere. We talked about the division of the atmosphere based on uniformity of molecules. That is, division into homosphere where there is somewhat some uniformity in the gaseous composition, and heterosphere where there is no uniformity in gaseous composition. Then we learned that the different layers of the atmosphere is divided or formed based on the temperature level, and these layers are the troposphere, stratosphere, mm, mesosphere, and the thermosphere. We also spoke about the how the temperature changes in each layer. In the troposphere, there is a decrease in temperature with altitude. That is, for every 165 meter, the temperature decreases by 1 degree Celsius. Then comes the stratosphere. The lower part is the isothermal zone, and beyond that, the temperature increases with altitude. In the mesosphere, the temperature decreases with altitude, and in the thermosphere, the temperature increases with altitude. And we talked about ionosphere, which helps in the transmission of the radio waves, and we talked about ionization process. That is all that we looked into today. Thank you.